Welcome to the first session of the JakartaOne Livestream. And with me here, I have Nicolas Frankel, and he will talk about shortening all URLs with Quarkus, Kotlin, Hazelcast, and GraalVM. So I'm looking forward to this. So show us your, Nicolas.
Thanks a lot, Ivar. Hi, everybody. Thanks to be here with me. I'm very honored to have the first talk today. It happens very rarely. And I'm very happy that it happens at the JakartaOne Livestream. So I'm Nicolas Frankel. I've been a developer for a couple of years. I've been doing team leading, architecting, and whatever. My main background is in backend in Java, and since 2 years, I'm a developer advocate. But today, I work for a company called Hazelcast. You might have heard about Hazelcast. We have two products. The first one is an in-memory data grid. And you can think about an in-memory data grid as distributed data structures. So instead of having a hash map inside your memory, then it's sharded and distributed all over the network. And the other is an in-memory stream processing engine. But today I won't talk about in-memory stream processing. I will just use Hazelcast for my demo, but that's not the main point. Today I want to talk to you about the cloud, and especially the cloud gold rush. Like, everybody is going to the cloud. You're a developer, you need to go to the cloud. You're a manager, you need to go to the cloud. If you're a company, you need to go to the cloud. Everybody needs to go to the cloud. So the cloud is very hype, and it's shiny, and it's bright. But actually, there are some reasons why you can consider going to the cloud. The first reason is actually cost visibility, not the cost itself, but the visibility. Like, if you have been working in companies before, you know that one of the metrics they are checking is the total cost of ownership. When you acquire material like a laptop, when you acquire a server, when you acquire some kind of hardware, well, you need to account not only for the cost of the acquisition, but the maintenance. But in some cases, it's harder to actually measure it accurately. If people work on the maintenance of the system, you need to track down how much time they spent on it and how much they are paid. And this is hard. This is actually very hard. So you have a fuzzy understanding of the costs. It might be good, but not that good. And when you move to the cloud, perhaps it won't bring the bill down, but at least you will receive your invoice and you know exactly up to the last cent how much it cost you. The other reason is flexibility. I like to use the example of an e-commerce shop, and the e-commerce shop need to prepare for Black Friday and Cyber Monday. And so when you acquire your hardware, you need to take that into account. You need to size your hardware according to your peak loads. And like Black Friday and Cyber Monday are the peak load. And the rest of the time, well, there is a gap between this peak load and your average load. And the rest of the time, this is just basically wasting resources. So if you go to the cloud, you can pay on average when you need average and pay on peak when you need peak. And the final point that I realized not that long ago is if you're a developer, a freelance, or you want to create your startup, well, the acquisition of hardware is actually a huge first step. It takes a lot of money to acquire a server, and perhaps you want redundancy and this kind of stuff. And in that case, using the cloud and paying as you go is actually the easiest way to start your company. So beyond the hype, there are a couple of reasons why you can consider going to the cloud. And if you are a company and you already have software assets, you probably want to move your software, your applications to the cloud. There are a couple of ways to do that again. On one side, you can just take your application as it is and just put it, deploy it on the cloud, like a lift and shift. Or you could say, no, that's not going to work. I will rewrite all my applications and make them cloud native. And I believe that between those two extremes, there might be a middle path. So let's check each in turn. Lift and shift is considering the cloud as just somebody else's computers. You know that, yeah, the cloud is just somebody else's computer. So you just keep that mindset and say, hey, so instead of hosting my applications on my own infrastructure, I will host it somewhere else. And most of the cases, it can be relatively easy. You just like containerize your application, and by saying just, of course, there are a couple of hiccups you might be encountering, but more or less you just containerize your app and you use one of the containers, of the platform that can run containers. Or if you're already using a Java EE applications, then probably there is an offering that lets you run an application server in the cloud, and yeah, you just ship it there. Well, let's consider the base case. The base case is it's probably going to be more expensive. Why? Because when you run on your own infrastructure, you are not considering like extra CPU cycles. If your algorithm, if your business logic wastes some resources, you don't care, because basically you acquire the hardware. So this waste is not accounted for. Now, when you lift and shift, now every bug that is not like impairing the business logic, but just waste resources, it's gonna impact your bill. And so on the best case, I believe it's going to be a bit more expensive. It can be, of course, a lot more expensive. But in the worst case, well, it won't work at all. And you might have come upon this 12 factors app. And this is just a reminder. My idea is not to go into each of them in detail, but basically those are 12 items that each application that needs to run into the cloud should comply to. And let's take a standard JVM application. And by standards, I will just have a web application that runs on Java EE compliant server. It might be a Tomcat application that you don't need everything, or it can be a full-fledged Java EE application. But the idea is to check. So the first one is, that there is a factor saying that your application needs to explicitly declare dependencies. And when you create an ER or even a war, well, there is one unexpressed dependency, is you are dependent on an application server or even on a servlet container. And that's an expectation you have, but you don't declare it. It's implicit. And you might say, okay, I don't care. I will just run embedded. So I will use Tomcat embedded or Wildfly embedded. And so I don't need to have an application server. Well, you just goes a bit further, but now you have a dependency on the JVM that you don't declare it as well. You just expect that when you deploy your jar, your self-contained jar, that the application will run as expected because there is a JVM with the expected version. And that's the biggest problem. Well, you don't declare your dependencies. Another factor that you break by using probably this kind of JVM application is the configuration. I mean, you probably are using a data source, and you are very happy that once you have deployed your data source, you can deploy your application from environment to environment, and you will just use this physical name for the data source, and in each environment, there will be a different data source configured for you. Well, that's just configuration that is expressed through the application server. It's implicit. You expect it to be so. An application that is cloud native should have fast startup. Well, this one is much bigger than just an application server issue. Like, you know that the JVM takes a long time to start up. And the reason for that is that at first, it will just run the bytecode, and for some cycles, it will analyze the workload. And after a while, it will understand, okay, this is the workload that is given to me, so I should optimize the bytecode, and now I can create native code that is optimized for this workload. That's the reason why the JVM has consistently, at least in the latest year, have had very good performance testing in regards to native code. It's because of these continuous improvements of the native code that it produces over time. But if you start the JVM at the beginning, first it will need some time to initialize everything. Then you will have an additional period where it will actually be not super performant. So for startup is definitely not something good for the JVM. And finally, if you are running in an application server, you probably have different log files. Like for example, Tomcat has at least 3 log files, plus perhaps your own log file for the application. And so all those logs, they are in different, they target different files. And so you don't have a unified log that you can stream to your monitoring system. So those has at least 4 factors that a standard JVM application will break. That's not great. And now if we add more fun stuff, well, your framework probably is doing some kind of reflection. And as you know, reflection is not super great regarding performance, and also class path scanning. And if you do both at startup time, well, it's going to increase even more your startup time. And again, it's one of the factors we try to optimize for. Why? Because, well, in the cloud, if a node seems sluggish, well, you probably just kill it and start a new one, and you don't care that much. Treat your infrastructure, treat your servers as cattle, not pets. They don't have a name. You don't care about them. If one of them starts behaving not correctly, then just kill it, start a new one. But again, the implicit expectation here is it needs to start fast. So the opposite way is to rewrite the app, because our JVM application is not on par, like it is not, cannot be lifted and shifted. Then we rewrite everything. And yes, on this side too, there are a couple of issues. The first, the obvious one is the cost of the rewrite. If you come to your boss and say, hey, we have this application, that's our core asset, and we need to deploy it to the cloud, and we need to rewrite everything because right now we cannot deploy it for the cloud. Well, how much does it cost? And then you say, 6 man months. And your boss probably is not going to agree with that, because with this cost, it brings nothing to the business. And whether you like it or not, right now, the business is still leading us. And so if you are spending money and it doesn't bring any benefit to the business, that's not going to fit well with the board. But now imagine you work for one of those companies. They have a lot of money. They are very engineering focused. Your boss just love to spend money, and he says or she says, yes, okay, let's do the rewrites. Well, there is another issue now. It's going to take some time to actually rewrite the application. And during this time, the issue is that, yes, the original software, the one that is not fit for the cloud, is going to evolve, because the business, even if it has a lot of money, it agrees to the rewrite, it will need to add more feature, because we need to keep up with the competition. And during this time, actually, the original target will actually move. So your rewrite will be chasing a moving target. It's very, very dangerous to do that. It's going to be a hard issue. And of course, you will be producing codes, so there are risks involved. The risks are there will be bugs. Not only a few of them, because yes, I mean, everybody of us, we are very good developers. We never write bugs, but there will be some bugs anyway. And finally, about the team, writing code, writing a new application will require more people. So do you recruit more people? And after the project, what do you do with them? Or do you use an outsourcing company to do that? And if yes, how do you organize teams? Like, the usual stuff is to let the old people that you keep write the new software, and like let the new people like maintain the old software. But probably your team knows the application much better, so they will always be bothered. Hey, I have a bug there, or I need to develop this new feature. How do I do it? So that's actually 4 issues that you need to tackle, and each of them is a complex one. So I believe that there is a middle path, and this middle path is, let's reuse the code that we have. For example, there could be annotation from Java EE, and change the way they are used to be cloud native friendly. And I cannot talk further without mentioning GraalVM. So I guess by now, most of you have probably heard about GraalVM. The thing about GraalVM is just a bag of a lot of different things. The first one is the standard JVM platform. So you can download GraalVM and use it instead of Oracle JDK or Adopt Open JDK. The second thing is it offers languages interaction, so that from your Java program, you can easily call a Python code or C code, or like the other way around. And the third thing is it's actually a framework to implement your language. It can be either an existing language or it can be a new language. So for example, there is this truffle Ruby. So it's a Ruby implementation that has been written using this truffle framework. But in our case, the most important and interesting stuff is Substrate VM. Substrate VM is also part of GraalVM. And this Substrate VM component allows you to create a native executable out from bytecode. It can be like dedicated class, it can be a jar, but it's able to do that. It's able to do that by doing some kind of ahead of time compilation, so that it will like actually find the main method, and it will like start to follow the execution flow from there. And it will follow it, and what it doesn't find, it will remove the stuff. So in the final native executable, you will only have the passes that were virtually executed. And of course, there are some issues with that. For example, one of the benefits of Java, as I mentioned, is reflection, runtime reflection. You can ask for a class you don't know and say, hey, what are your methods? What are your attributes? And I can call it, I can call you without knowing about it at development time. And this is actually very hard, because when Graal will follow the execution path, well, it won't be there. This class won't be there. So that's at runtime, you will have a bug. It's possible to configure those calls so that you need to tell Graal, hey, don't forget about this class. You didn't find it yourself during the execution, but yeah, just keep it because we will be using it. For non-trivial application, you will find it that the configuration file for reflection is very huge. For that, you have an agent. So you will run your application normally using a dedicated Java agent, and it will record it. This agent will record every call and write the configuration file for you. So afterwards, you don't need to write it yourself. Another issue is, well, it's not cross-platform, meaning that if you download GraalVM for Mac OS X, for example, which is my platform, well, you will create a Mac OS X native executable. So you need to do the same with Linux or Windows or whatever. If you are doing containers, for example, that means that your GraalVMification, your native executable creation, needs to be built inside the Docker file. Just use a multi-stage Docker file. So this is a summary. JVM versus native executable. It's not saying that JVM is bad. It's not saying that native is good. It means that depending on the context, JVM might be better or native might be better. And in the cloud context, well, JVM is not that great because it consumes a lot of memory compared to a native executable, and the startup time is higher, is longer. Of course, then if you write a native executable, then you don't have these write ones run everywhere, and you don't adapt to the workload, but those are considered good trade-offs in the cloud native world. So there are a lot of frameworks that began popping up using those features. And actually, all that I know of, they use this substrate VM stuff to create a native executable, and they actually also remove reflection to be a build time consideration instead of a runtime consideration. And those are the frameworks that have popped up yet. So there is Micronode by Object Computing, there is Quarkus by Red Hat, there is Elidon. I didn't have a check at Elidon, to be honest, so I cannot talk about it much, by Oracle. And of course, there is Spring Boot, but Spring Boot is not Java EE. So just so you know, if you are a Spring Boot user, you can use it, but this is out of scope right now. So now I want to do a demo, because if I'm just talking, it's not that interesting. And I want to create a URL shortener. This will be my use case. The traditional approach when you write a URL shortener is to create a bijection between two spaces, the space of all URLs and the space of your shortened URL. And yeah, you need to go from one to the other, or to the other to the one. And you need to handle somehow collision handling, because the space of URL is much bigger than your space of the shortened URL. I will use an alternative approach. So what I will do, I will just have no algorithm. I will just generate random short links, and I will store the bindings between the few URL and the shortened URL. And I will actually have store those mappings into Hazelcast. And so this trade-off in that case, instead of having an algorithm with a lot of CPU time consumption, I will just consume more storage, which is fine. So my stack will be a legacy Java EE application. Everything that will show you will be Java EE compliant, because still I need to want to show off a bit. I will write everything in Kotlin. I will be using just JaxRS, and as I mentioned, I will be storing the data is in INDG. So this is my application right now, and it's like a legacy application. I'm using the JVM, I'm using Tomcat, and inside of Tomcat, I'm like having this war stuff. And this war has, of course, in the web and flip, an additional jar that lets me talk to Hazelcast INDG. So when I have a user sending an HTTP request, then Tomcat, through its many jars, does its magic, and it directs my requests to my controller, and through my controller, I either get or put the data into Hazelcast INDG. So this is the application right now. As I mentioned, I want to make it cloud native. So the idea, I will be using Quarkus. And with Quarkus, I can already remove completely Tomcat. So it will still be using the servlet jar, the JaxRS jar. But when I receive a request, instead of having this Catalina jar doing the magic, I will have the Quarkus jar doing the magic. And I will just need to change the Hazelcast client to a dedicated Quarkus Hazelcast client. I can still do exactly the same. And everything will run into a self-executable jar. This is good, but I'm still using the JVM, and I want to keep using the JVM in development. Why? Because yes, I know how to debug, I know how to set breakpoints, I know to when I'm in breakpoint, I want to know how I know how to keep the states or to see the states of the variables. That's something I'm used to. I want to keep all those nice tools, so I will just still be running inside the JVM. But when I decide to deploy it to production, I want it to be cloud native, and hence I want to remove the JVM. And this is the to-be state in production. Everything that was running inside the JVM now has become a native executable. I kept this diagram. I don't know how it works inside. I have no clue how it works inside, but it's probably the same. And I can still, of course, talk to Hazelcast. So again, I've talked a lot, and yeah, let's time for some code. So how do you start with Quarkus? Quarkus actually has a command line interface through Maven, so you can scaffold on your project. This is exactly what I did with this POM. So I'm using a POM. I'm not using Gradle. And yeah, I didn't have to write anything. So I said, hey, I want to add JakartaOne, and I wanted to add Kotlin, and this is what it created for me. As you can see, there is nothing really mind-blowing. Just at the end, you have this profile that will be used afterwards to create the native image. But that's all. I will close all other tabs. And when it scaffolds it for you, it creates those two files. So this Docker file JVM, it lets you create a Docker container, but that will still run through a JVM, or it can it creates this Docker file also for you, and this one will create a Docker container that will run a native executable. The code is actually pretty simple. I have this controller annotated with JakartaOne annotation, and I have a couple of URLs. The first one, hey, when I post this URL, then I will actually create a random string and I will store it in IMDG. And when I will do the opposite. I will check in IMDG for the shortened URL. And here you can see that when I put something in the in-memory data grid, I have added an automated code execution that if if I need to put in one map, so I have two maps, the maps of the URL where the key is the long URL and the value is a short URL. I have the opposite one because I need to do the bijection. So if I put something in the shortened URL, I put it in the long URL reverse. So the value becomes the key and the key becomes the value. I have this random stuff. So this is how I generate the URL, but it's not very interesting. So let's see how it works. The first thing that I need to do, I need to start Hazelcast. Hazelcast start. Now I will be running inside the JVM normally. And I will run this mvn compile and Quarkus dev. So it takes a bit of time to start, but normally everything has been compiled already. I have some incompatible versions, but that's not an issue. And now what I will be doing, I will be checking my nodes. So I will be creating a new binding. And here I will be curling here. So I create this http foo.xyy, and it returns me this shortened URL, which in that case is not that shortened, but bear with me, is just a stupid example. Now, if I want to check it out, I will just curl it. And so I have this bijection. So I stored a new a long URL, and it creates me a short URL, and I ask it for the short URL, it returns me the long URL, which is basically URL shortener. So I've checked that inside the GVM everything works, and I want now to do like a deployment on the cloud. So I will create a container, and this is the thing that I need to do right now. And to be honest, I won't do it for you because it takes a long time. Like I did it just before. It took like 7 minutes. Granted, I had to download part of the image. Some layers were there, some layers were not. But let's say it will be taking 5 minutes, which is not fun. So what I will just want to show you is, in the end, I will be having this kind of stuff. Targets. Yes, targets LH. So I will be having this like 59 megs thing. This is what it will create. And afterwards, I can, with that, create Docker image. And afterwards, I can have this Docker image, and I will Docker images, grep URL shortener. And here you can see that the final image is like 170 megs for a native executable, which is not that small, but not that big either. It's probably like, because I'm using this parent image, which is a bit huge. But if we do the same with the GVM, you can see that it's taking 3 times more space, and not taking about memory, resource consumption, or startup time. Is just like the space it takes. So as you can see, native executables are also much smaller. And how does it work? Well, I will be doing the same. I will be using this application and Hazelcast itself. I have everything in a Docker Compose file, so I just need to start Docker Compose. Up. So everything is working, and now I will be curling again. And yeah, I'm doing that every time because I don't want to mistype something. So let's check that it has been stored in the Hazelcast Docker image. Yes, it has been stored in the Hazelcast Docker image. So yeah, this is it. This is the demo. So let's get back to the presentation and recap everything. So when you are tasked to deploy to the cloud, you can lift and shift, or you can rewrite everything. But there is the middle path, and you should work it when possible. So use existing codes, use framework that you know, that know how to leverage your codes, and you will have the best return over investment, I believe. So thanks for your attention. You can read my blog. You can follow me on Twitter. You can have a look at Quarkus Hazelcast integration. You can have a look at the codes that I showed you. The code repository is available on GitHub. And of course, you can join the conversation about Hazelcast if you're interested in distributed systems. And so thanks a lot again. Perhaps there are some questions. So I see there is a question.
Yeah, there is one.
Is it possible to debug Quarkus when it is building the image? And that's the fun part. I must say that it's not about Quarkus building the image right now. It's more about the like image building, the native executable creation feature of like GraalVM, and it's very, very hard. So in some cases, you will see this big error message, and I've already like wrote a bit about how you can debug it. It's very hard. This is, I mean, in every technology, there is this like curve, and right now they are very focused on the features, and the usability is not super huge. So far, I didn't find any way to easily debug. In general, I tried a lot of different parameters. For example, I say, hey, like instead of like doing that, initializing this class at runtime, initialize it at build time, or otherwise there is a Slack also on GraalVM. Can we still use GStack or Flight Recorder after building the project into a native image? I don't use GStack or I don't use Flight Recorder, but I would assume that there is a chance of nearly 99.99% it's no, because now it's a native executable. So everything that you have been used to in the GVM, you can just say, hey, goodbye. And you need to use tools that are used by people who are writing C or C++ applications. So thanks, everybody, for your thanks. Do you still have other questions?
I don't see any questions, neither in the chat nor in the questions section. But we're thrilled that we had you for this conversation today. We're hoping that you will explore further Jakarta related technologies and Helidon, and next time around maybe we can have a presentation on that and see how that goes. So
I will be happy to.
Yes.
So thanks again, everybody. If you were too shy to ask your questions in public, just ping me on my Twitter and my DMs are open. So for everybody, oh, sorry, I'm learning Java last 3 months. Can please suggest me framework from where I learn? Oh, that's a huge question. I'm sure the community will have a lot of different answers for that. So please allow me not to answer. And good luck for everybody. 12 hours. Oh, no, like 11 hours now of broadcasts. That's a lot. So good luck. Thanks a lot. And see you soon. Bye-bye.
Yes. Thanks, Nicolas. Kartik, hang out with us and you will hear about many different Java frameworks. These are kind of focused on enterprise Java development, tons of things to learn, and just hang out with us. Okay, so I think I'll just give a signal to Ivar and Hudson here to pull us into different sessions. So see you shortly in the next session.
Bye-bye.
Bye. Thank you again.